I'm George Tekmitchov. This is World Archery Asia's Compound Fundamentals Class 1 on compound bow. We'll be getting you acquainted with the compound bow in the next few minutes. We'll be talking about the mechanics and history of the compound bow. We'll talk about the important things when we consider the tuning of any compound bow. We'll touch on arrow selection, and we'll be getting a step-by-step basic tuning process with world champion, four-time world champion, Jesse Broadwater, later in the presentation. We'll also talk about aiming and shot execution and adjustments to the compound bow that affect these factors. So we hope you'll enjoy this presentation as we delve into the compound. Compound bows only have a little more than a 50-year history. The story of the compound bow began in around 1966, and it became available starting in 1969. The real story of the compound bow is that it more effectively manages and transmits energy to arrows than any bow that had been created in human history up until that point. Now, all bows store energy as they're drawn and then release that energy into the arrow when we release the string. But a mechanical control system is what makes the difference with the compound bow. And figuring out how to tune that mechanical storage system, that control system, is the main focus of today's presentation. Wilbur Hollis Allen, a man from Pennsylvania in the United States of America, created the first compound bow. In 1966, he applied for a patent, and it was issued in 1969. The secret of Hollis's specifics in terms of his innovation is that he came up with an eccentric cam that causes the compound to store more energy than recurve or longbows at the same draw lengths and peak poundages during the draw. The blue line you see here is the energy storage of the compound bow. The red line shows the energy storage of the recurve bow. The area under the line is the stored energy. So you can very easily see that for the same draw maximum weight, we're getting a lot more energy storage from the compound bow. In addition, the compound bow gives you let-off, which means that when you reach full draw, the weight dramatically drops, sometimes as much as 90%. For target archery, generally competitors prefer around 65 to 70% at the most, but the compound bow is capable of even more. Some called it the first major mechanical advancement to archery in 50,000 years of human history. The original compound bow was fairly crude by today's standards, but at the time it was introduced, it was a revolution. The first time that World Archery accepted compound bows for competition was in 1991, where in Oulu, Finland, it was used for the championship in the World Indoor Competition. Another aspect of compound bows that sets them apart from recurve bows and long bows is that they have a set draw length. When you pull the bow, you reach a stop position beyond which you cannot pull further. You can increase holding weight by pulling harder into the stops that are built into the bow. However, the bow will not generate more power past that point. The mechanical control system of the compound also creates let-off, reduced holding weight at the full draw position. This makes it easier to focus on other elements of the shot process, like aiming or execution, and that makes things different than the story we have with the recurve bow, where we're worried about things like aiming while we're trying to pull through the clicker, and of course focused on follow-through if we're doing things right. As mentioned previously, the cam system, the eccentric cam, is the key to compound function. Over the past 50-plus years of compound development, there have been many different cam systems used. There have been 4 cam bows, even 6 cam bows, and 1 cam bows. Today, the most accurate and popular compound bows use a slaved 2-cam system to ensure timing and consistency during draw and launch for each and every shot. But perhaps the greatest change from the compound bow is related to how it's used with a release aid. The greatest accuracy advantage of the compound bow really derives from the use of the mechanical release. Most human variables, from shot to shot, are attributable to release. Of course, for thousands of years, thumb rings and other sorts of rudimentary mechanical releases have been used in archery, but today's modern mechanical release eliminates many human variables and allows focus on other aspects of shot execution, like a steady hold. Before we go further, let's talk about safety precautions for the compound bow. Please consider the fact the compound bow is storing enormous energy even when it's at rest. Most compound bows today have more than 400 pounds of stress in the limbs and in the bus cables and the bowstring itself. So it is essentially an energy-packed system. You should never attempt to draw a modern compound bow with fingers on the string, especially those that are designed only to be shot with a release. You should only draw with a release device while keeping the bow in a safe direction at a suitable target or backstop, and always only draw the bow loaded with an arrow that's at least 2 inches longer than the maximum bow draw length. If you have a condition of misaligned cams or cams designed for release aids, and you draw them with fingers, you may derail the cams, that is, have the strings jump off of the cam, and you can cause serious injury to yourself or to bystanders, and you can destroy the bow. Safety glasses are mandatory for any maintenance work you conduct on a compound bow. Another important consideration, peep sights, which are used in almost all target compound bows, must always be served securely into the string. An unsecured peep sight can fly loose from the string during a shot or a dry fire. It can rebound off the riser and can seriously injure the archer or bystanders. In fact, in the past, there have been at least 2 cases where archers have been killed in such a manner. Never allow the bow to collapse toward the archer in a letdown either. The cable guard or the arrow rest might seriously injure you in an uncontrolled letdown. Fingers and long hair needs to be kept clear of the cam system and cables at all times when handling the bow. It's important to pay attention to the mechanical condition of your cables and your bowstring because they store many hundreds of pounds of tension, even at rest. And as with any bow, sky draw is dangerous, and especially from a compound where arrows can easily travel more than 400 meters if let loose at an angle. Now, cam systems are the heart of every compound bow. The cam is what helps store energy. It has a tremendous effect on how the bow feels during the draw, and it has a big effect on the arrow at launch. We control the draw weight of a compound bow with the geometry of the cam system as well as the stress in the limbs. So the required effort rises and then falls during the draw cycle. Remember our blue line on the chart. The draw cycle is mechanically manipulated by the shape of the cam to maximize energy storage or to make the cam feel smoother. Generally, less effort is required at the beginning and the end of the compound bow draw stroke. Somewhere in the middle of the draw stroke is where you're going to have peak poundage, and because the peak poundage lasts longer on a compound than on a recurve, you store more energy. Peak weight of the compound bow is where the maximum draw effort is required, and that is where we measure the compound bow draw weight, the heaviest point of the cycle. This peak weight is the engineered weight for the bow as specified by the manufacturer. Remember that when we're talking about world archery competition, 60 pounds is the maximum peak weight for a compound bow. At no point in the force draw curve can the bow be heavier than 60 pounds. Holding weight can be as little as 10% of the peak weight on some cam systems, as we've mentioned previously. However, for target archery, most competitors prefer their holding weight to be between 65 and 75%. The proportion to peak weight to holding weight is known as let-off. If a bow has more let-off, it has a lower holding weight compared to the peak weight. So when we talk about 65% let-off, that means that the holding weight is 65% of the peak. If we talk about 90%, holding weight is 90% less than the peak weight. The shape of the cam system can generate different performance curves. All of this is about energy storage. High-performance cams, which tend to be more oblong in shape, generate more energy storage. However, they can be harsher to draw. The shoulders that you see on the chart actually feel like a big change in weight, and as a result, it can change the feel of the draw and make it feel harsh. A smoother draw with rounded edges to the force draw curve feels better when you're pulling, and also if you have to let down, but it stores less energy. Most target bows are set up somewhere in between these two extremes. So again, rounder cams tend to reach their peak weight more gradually and tend to draw more smoothly, but more eccentric cams, like this Hoyt SVX on the right-hand side of your screen, tend to store more energy, but also have a steeper weight increase early in the draw, and in particular have a very increased amount of drop at the full draw position, which means that the archer must maintain tension all the way through the shot. The highest performing cams have the shape shown on the right, while smoother cams have somewhat less speed, but can be much more comfortable to shoot over the long term. The holding characteristics of a bow can be characterized by what's called the valley. The valley is the area in which the bow holds at its lightest weight at full draw. If you pull further, the bow gets heavier, but it doesn't generate any more power. Smoother draw cams often have a longer valley. The advantage to this is if you have a slight bobble in your full draw position, the feel of the bow isn't going to try to snatch the full draw from you. If you're shooting a high-performance short valley bow and you let up as much as 1/8 of an inch, suddenly the weight can jump, whereas smoother cams have a longer valley, a more forgiving position for full draw. Another important characteristic of the modern compound bow is that it is a closed-circuit system. That means the cable system connects each cam directly to the other cam. So this forces the limbs to be in balance with one another. While it is possible to make adjustments by tillering the bow, increasing or decreasing the weight of the top and bottom, generally speaking, the modern 2-cam compound bow is designed to be shot at 0 tiller. Now, recurve bows, of course, can be drawn as far as you can physically pull, but a compound bow is usually engineered to draw back to a very specific length and then come to a dead stop. This distance is known as the bow's draw length, and the mechanical systems on the bow, such as the small object you see on the cam over here on the right side, is what controls that final draw length. That is adjustable on this particular cam that you see. Determining draw length fitment begins with measuring the archer and then finding a bow that can adjust to fit that person. It's important to adjust the bow to fit the archer, not the other way around. The correct draw length for a compound is the draw length for the individual archer where they're the most comfortable and can hold the steadiest at full draw with the best accuracy and comfort. A very small change in draw length might create a big change in steadiness at full draw. Many bows are capable of small adjustments to draw length through changes in twist count to bus cables, to string twists, or to cam and cam stop adjustments. Some bows, like the Hoyt Invicta and their new Stratos model, also allow further draw length adjustment with grip modules. These are small modules that install into the grip with different heights for very small adjustments to draw length. Compound bows are designed to be shot from the full draw position, that is, with the bow drawn all the way back and pulled into the stops. If a compound bow is set for a 29-inch draw length, it should always be shot from that full 29 inches. You should not try to shoot from creeping up the valley or shooting from the middle of the holding valley. Now, on most compound bows, the mechanical stop at full draw can be quite firm. However, some bows have an adjustable stop that can feel softer at full draw. Some shooters may prefer that feel. Hard stop bows can be useful as an index for shooters using back tension type releases. Now, as we talked about earlier, most World Archery compliant compounds that have a maximum weight of 60 pounds hold at less than 25 pounds of pressure at full draw. Again, it's important not to relax the draw at any point while holding, because some bows with high performance cams and a narrow valley can snatch at the draw if you let up slightly and can cause an uncontrolled letdown. The string loop, which is almost universally used by target shooters today, can be used to make adjustments to how the bow fits the shooter. However, keep in mind the fact that measurement of the draw length of the bow is not using that string loop as part of the draw cycle. If you draw a compound bow back to full draw, the draw length is from the knocking point on the string in a line perpendicular to the center line of the bow to an imaginary point above the pivot point of the grip plus 1.75 inches. That is the industry standard. So the string loop is not part of the bow draw length. And the reason this is important is you need to keep this in mind when you're selecting arrows. When the arrow chart calls for the bow draw length, do not count the length of the string loop. Again, you can use the string loop to make an individual adjustment for a specific archer for where their hand sits at full draw. However, do not count it when counting how much energy is being stored by the bow. At full draw, your anchor point needs to have several key reference points depending on the physiology of your face and body. Commonly, reference points are nose to bowstring, arrow nock to the corner of your mouth or jaw, a kisser button which can touch your lip, your hand against your cheek, your knuckle touching your jaw or your ear. But a string loop has no effect on how the string itself touches your nose or how the nock of the arrow touches the face. It will, however, position your release hand about a ½ inch further back on your cheek, and that might give the feel of a longer draw length and can help or hurt biomechanical alignment. Compound bows are generally designed to have an individual weight range which is set at the factory. Some compound bows have a very wide weight range, but generally these reflect a compromise in the design of the bow. They will not necessarily be the most efficient at all draw lengths. High-end target bows are generally sent with a fairly narrow weight range, and the factors that affect the weight adjustment are primarily the limb bolts, which controls the preload on the limbs. In just about every case, you must be careful not to exceed the maximum turns on the limb bolt when making adjustments. Most bow manufacturers specify the maximum number of turns, or revolutions, that the bow's limb bolts can be safely backed off from the fully tightened position. It's also true that most top target archers prefer to shoot the bows at their full weight position. Weight changes can be made with small changes to bus cables or string lengths. This is via twisting or removing twists from those bus cables or strings. Different bow systems are affected differently depending on how many variables, including cam design, limb preload, limb angle, and the presence of or the absence of yoke systems. Keep in mind that bus cables can be very sensitive to twist and therefore weight changes. And remember also, changing the twist rate on one bus cable can change cam timing on the opposite cam. Cam timing is the difference in rotation between the top and bottom cam, the synchronization between those cams. Most bows are set up in such a way as to have the top and bottom cams synchronized in motion to each other. This can affect lots of different variables. It can change the way the arrow leaves the bow. It can change the delivery of power on the shot. It can have a change of the feel of the hold at full draw. It can change the shape of the force draw curve and the energy storage, and other important elements of the interaction of the bow and the archer. Now, generally, manufacturers will design bows with a relatively narrow range of optimal cam timing. However, many archers like to advance the top cam slightly, which can affect the linearity of the draw, the slope of the weight ramp on the draw, the relative feel of the cam stop, and other factors. A slightly advanced top cam means that the top cam is rolled further forward than the bottom cam. Very small adjustments to cam timing can have a big impact on the feel of the bow. Some archers like to advance the top cam slightly, which affects the slope of the weight ramp on the draw. So when we look at what that means in terms of energy storage, the yellow chart shows the shape of the energy storage, and you can see that there's a bit less energy stored under the curve. Also, the maximum weight of the bow comes in earlier during the draw cycle. A synchronized cam can feel more consistent through the heaviest part of the draw, but a top advanced cam can sometimes lead to the bow starting out heavier and then feeling lighter as it drops down into the valley. This can be desirable for many target shooters. One of the most important aspects of the compound bow system is the arrow rest. But unlike the recurve bow, the compound bow arrow rest may be in contact with the arrow all the way through the entire launch sequence of the arrow shaft. Because of this, Clearance is a very important consideration when you select the arrow rest itself, when you set up the arrow rest, and also when you select and set up the arrow. In particular, the fletching and knock system selection of the arrow is important to maintain good clearance. The biggest cause of clearance problems is interference between the vanes of the arrow and the arrow rest itself. Narrower blades or bigger arrows generally provide for better vane clearance. Of course, outdoors, most shooters are using X10 size arrows, and as a result, they'll be using narrower blades. The blade is one of the most popular means of setting up the arrow rest, and the vertical angle of the launcher blade is a big variable in tuning. Also, the width of the blade has a bit of effect on the stiffness of the blade, but the stiffness is affected most by the thickness of the blade. Different blade thicknesses can provide for different amounts of flex vertically, and it's important to manage the blade flex relative to the arrow spine and the clearance of the arrow. Some popular blades are available in 8/1000ths of an inch thickness, 10/1000ths of an inch thickness, or 12/1000ths of an inch thickness. In the example shown on the right, the Jesse Broadwater endorsed Freak blade provides for 150/1000ths of an inch of separation between the blade tips and is ideal for small diameter outdoor target arrows. The wider blades on the right side of the chart are better used for larger carbon arrows and aluminum arrows for indoor competition. Arrow selection is an important aspect of successful compound bow setup. One of the great characteristics of the compound bow, though, is that it can work with a wide range of spines, a much wider range of spines than a given recurve bow can. This is because of how the compound launches the arrow, and also, critically, the elimination of most of the variables of a finger release. For a given archer, their finger release has a large impact upon the ability of the arrow to cycle out of the bow with good clearance. With the compound bow, this is no longer a problem. Generally speaking, it is always possible to get a slightly too stiff arrow to properly tune for most compound bows. The best grouping setups tend to have good matches to spine. One of the top archers in the world is Jesse Broadwater. For many years, Jesse has been at the pinnacle of competition in terms of both his achievements as an archer and also as a bow mechanic. So let's take a few minutes now to hear from him and his philosophy on how to set up a compound bow straight out of the box.
Jesse Broadwater, we'll use that for an outtake. Jesse Broadwater, you're obviously, as a legendary shooter, over the years, you've become somebody with a great reputation for having both the mental side and the technical side of our sport dialed in. Talk to us about, start to finish, what do you do when you get a bow out of a box, compound bow? How do you start?
Well, it's not as complicated as what a lot of people think. And like now, with there being so much information at everyone's fingertips, you know, they're getting different information here, different information there. I try to keep it as simple as possible, and I base everything around how a bow groups, like how it groups and how forgiving is it. I don't care what I have to do to the bow to get it to tune. You know, if I got to shim a cam, if I got to lean the cam, if I got to run my center shot inside of where it's supposed to be, or, you know, none of that stuff bothers me. It used to. Like, I wanted to always have my bows, you know, everything right down the middle, and I didn't like a lot of cam lean and this and that. But at the end of the day, none of that really matters. It just matters where your arrows are impacting, and is it forgiving, and is it predictable. So I base a lot of my stuff around just group tuning. So I'll get a good initial setup, you know, and honestly, I just eyeball stuff, you know, for it to get the initial setup. I'll eyeball my knocking point. Now, there is a couple things that I do take a little closer measurements on, like my loop position on the string. You know, with the Invicta bows and some of the newer Hoyts, there's a place where I like to be on the string that gives me the kind of the hold that I'm looking for. So I run my knocking point. I'll start off at 90 degrees, and I run the bottom of my arrow through the center of the rest mount holes. So once I got that established, I'll just eyeball my center shot, kind of, you know, eyeball up and down the riser, get my center shot pretty close. throw on a, general stabilizer setup that I'm used to, and I know kind of after shooting for years kind of where I'm going to be. 30-inch rod out the front, 15 out the back, 7 or 8 ounces on the front, maybe 12 to 15 on the back. Get all that set, and then go ahead and make sure the draw length's right. Make sure the bow fits you right, first of all, before you go tuning or try to group tune or anything. And then I'll shoot one through paper sometimes, not all the time. And I'm not looking for a perfect bullet hole, but I'll just kind of get it close, make sure it's not, doing anything real funky like a 3-inch low right tear or something like that. And then I'll literally, if we're in outdoor season, I'll walk to 90 or 100 yards and just stand there and group tune. And what I'm looking for and what I'm adjusting when I'm group tuning is basically just moving the rest around minute amounts. And you got to do it on a day to where it's not windy. Do it at a distance where you're comfortable with, and you know generally what you can shoot at that distance on a non-windy day. So I know, like at 100 yards, what my groups, what I'm capable of, and so I base everything off of that. And if I get to 100 yards and I start shooting groups and they're, I'm just not hitting behind the pin, it's not predictable, and I don't break perfect shots all the time, but you should be able to call your shot. If you break one and it feels like it's 6 o'clock, you should be able to call it. It's probably 2 inches low at 6 o'clock. Well, if it goes high 7 inches at 1 o'clock, and you're constantly can't call your arrows and it's unpredictable, then you don't have that's what I call unforgiving setup. So at that point, if I have that going on, I'll just go ahead and move my rests. I'll just pick a direction, whether it be working off the vertical axis or the horizontal axis. I'll pick a direction, move my rest, say a 1/16 of an inch, and re-sight in and reshoot it. And you'll find, once you move the axis of the rest around, the X and Y axis, you'll find a sweet spot to where everything just kind of comes together. Your groups will get better. It'll be more predictable, more forgiving. Now, there is a certain, you still have to take arrow spine into consideration, arrow length, your fletching, your offset, your point weight, all of that. Like, you can't just go to 100 yards with a, 22-13 with 4-inch vanes and, expect to shoot, 3-inch groups or something. So you have to, kind of base your arrow selection off the Easton charts. But even I am kind of on the weaker side of where most people think I should be. Like, I shoot 60 pounds at 28.5-inch draw, and I run a 520 spine with a 140 grain point in my Pro Tours, which, a lot of people would say that's pretty weak, but I've found that they group better for me at distance and are more forgiving than, say, a 470 or 420 spine. So that's basically what I do outdoors, is just, get to a distance, group tune, move the rest around. Sometimes I'll work with a little bit of poundage or tiller to kind of fine tune the loop position or poundage. Then a little bit of stabilizer setup, fine tune that for the hold. And then indoors, all I do, it's the same thing, but I'm just doing it at 20 yards. So I'll shoot. It usually takes me a little longer indoors because it's not as critical at 20 yards. So I really have to shoot more rounds and kind of see what my average is on a Vegas target. If I shoot a week long of 28x average, then maybe I'll make a tweak, shoot another week, over a week span, see if my average goes up or down, see if I made a positive change or not. But that's basically all I do. And then after I establish a good, forgiving, predictable setup, then I will, at that point, run a bear shaft through it, only to check just where my tune is, so I can basically make a note of that in case something comes out of tune. Say if I get the bow tuned at 20 yards and I shoot my bear shaft through there and it hits an inch low of dead center at 6 o'clock, then I know that's where my tune is. That's where my tune needs to be if something ever changes. And, I feel like the bow's not shooting right, I'll run the bear shaft through it again. And if it's not hitting in that same spot at 6 o'clock, I'll move stuff around and get it back to where it's hitting that same spot. So that's basically all I do. It sounds pretty unscientific, which it kind of is, but like I say, over the years, I've learned I've learned what to kind of worry about and what not to worry about, and what to stress about and what not. And that's just, it's just one of those things that I feel like if you spend too much time on actually working on the bow and tweaking on it, trying to get it how you think it should be, rather than actually getting out there and shooting it and seeing where the arrows land, because that's what matters in the end. You know, what's on the scorecard and where your arrows are impacted. So that's all I worry about now. So that's basically the simplified, long-winded version of what I do.
Knock fit and its role in tune. What happens with knock fit as far as you're concerned?
Yeah, so knock fit. I do have a theory on that. I do like my knock fit a little bit on the looser side. So say if I'm running, say on my Pro Tours, the Easton pin knock, the large groove pin, the G pin, I like my center serving to be 107 thousandths. That if you have it 107 thousandths with the G pin, you can knock it on, you can move it up and down very freely, you can even rock it side to side a little bit. You know, you turn the bow to where the arrow is pointing straight down, just give the string a little pluck and it's going to come off pretty easy. So that is one thing that I do feel adds to forgiveness for me, is I kind of err on the looser side of knock fit rather than the tighter side.
Tight enough so that you're secure when you have to let down.
Correct, yes. Yeah, the arrow still stays on when I let down, you know, so yeah.
Blade angle and blade tension, the relationship between the two.
So that's another thing that if I can't, when I'm group tuning, if I can't get it how I want it, you know, I may run into changing blades. Generally with a Pro Tour, with the weight that I shoot and everything, I'm going to be an 8/1000 blade. The rest that I shoot makes two different lengths, 8/1000 blades. So I really have never found where I need anything stiffer than an 8, but I will play with, you know, different length 8/1000 blades, and then sometimes with the angle a little bit. Obviously, when you lay the rest down flatter, it's going to make it act like it's a little bit softer. And I do kind of have a theory. There's kind of been a theory out there to where if you're getting any kind of vein contact or whatever, you know, with the smaller arrows, it's hard to get on some setups complete 100% vein clearance off of a blade rest. But if there's a theory out there to where if you have a softer blade, or if you have the blade laid down a little bit farther, that blade or that vein contact doesn't matter as much, because it's kind of more absorbed and not going to affect the arrow coming off the rest as much if it does happen to contact it. So that is another thing that I will kind of play with if I can't get it out. I guess I've just been accustomed to, like, the rest that I shoot is kind of designed to where when you have everything like 90 degrees and true and plumb, it's at the angle that I've shot over, you know, for years and years. So I generally don't mess with that too much unless, you know, like I say, it's a rare occasion if I have to play with the blade angle to get it to group tune.
So there's the word from the World Outdoor, Indoor, and Field Champion Jesse Broadwater, who I would personally like to thank for taking the time to join us for this portion of our discussion. Time for questions and answers.